All right. Um, here's my name. Smiley face. Okay, so I'm going to go ahead and go through this with you and hopefully help you review a little bit because I'm not there, which is a little tricky. But this way you can kind of take a look at it whenever is best for you. So I'm going to graph both these lines. When you graph to estimate the solution, you're going to see where they cross. So this line starts at -7 on the y-axis because it's mx plus b. So 1, 2, 3, 4, 5, 6, 7. Here's the y, here's the x. And then according to that slope, I'm going to count up 1, 2, 3, 4 over 1. Okay. And then I'm going to go ahead and draw the straightest line that I possibly can. Thank you, Notability Geniuses. And then I'm going to go ahead and graph the second line. This is like having a plus 0 at the end. So it's going to start here, go up 1 over 2. Oh, bingo, up 1 over 2. So I already can see where they cross, even though my line's kind of terrible. And so they cross right here. Appears to be at 2, 1. If it's worth $1 bazillion, I plug this in for x and this for y to check. So I'd have 1 equals 4 times 2 minus 7, which is true because that's 8 minus 7. And 1 equals 1/2 of 2, which is also true. So you don't have to check it, but you can check it. This one, I'm going to go ahead and start at a +1 and then count down 2 over 1, down 2 over 1, down 2 over 1, and so on. Up 2, back 1, up 2, back 1. I just am terrible at drawing lines, honestly, so I am making as many dots as possible before I try. Then I'm still going to struggle. Then second one is gonna, okay, so you can do this a couple ways. I know that you know too, like to do it this way if I can, where I put a 0 in here. That would eliminate this part because 2 times nothing would be nothing, leaving me with this equation to solve. We did this a lot with linear programming. That was a really aggressive y, so let's try that again. And so then this would have to be a -4 in order for -4 times y to be +16. If I put in a 0 for the y, this part would go away and I'd be left with 2x equals 16. So I'd have an 8. So 1, 2, 3, 4, 5, 6, 7, 8 on the x, because that's what it's under, and then I go connect that to the -1, 2, 3, 4 on the y, because that's what it is under. Now, if you really, really, really don't like to do it that way, then you would have to go and figure out how to get it in slope-intercept form. And you would do that by moving the 2x over through subtraction. So I subtract that 2x to the other side, and then dividing every piece by -4. So y equals, here the negatives cancel, and the 2/4 reduces to 1/2 x, and then 16 divided by -4 is this. So I'd start at -4 on the y-axis and go up 1 over 2, up 1 over 2, up 1 over 2. So regardless of whether you do it that way or the way that I typically do, it create the same line as long as you do it correctly. And they cross right here, which appears to be at +2 for an x value, down 1, 2, 3 for a y value. But again, if I want to be sure on my test, I'm going to go ahead and plug them in. Plug this in for x and y in both equations. So the top equation, 3 goes in for y, 2 goes in for x. And is it true that -3 equals -4 plus 1? Yes. Bottom row, 2 times the x value that I got, which is 2, minus 4 times the y value that I got, and then I'm checking to see if it equals 16. This is going to be 4 plus 12, so it does. So I can know that that is correct, because the graphing ones can be tricky to see if you don't graph perfectly. This one's asking me to use substitution. You have to show all your work. I hope I don't have to do this. That would be awful, but let's find out. So substitution requires an x or a y to be alone, and that way you can replace it with its equal. They're identical. So what that means is since this y is the same as 4x minus 1, then this y is the same as 4x minus 1. So I rewrite that bottom problem, but I replace it with 4x minus 1. And then I throw down my tracks and start solving. This is going to be distributing. So 12x minus 3. These are on the same side, 1x plus 12x, so I get 13x. I'm going to go ahead and add 3 to both sides. I'm just doing some algebra 1 solving. And I'm going to divide by 13. Now, I found out that x is 2. So keep in mind, when you write your answer, x goes first, alphabetical order. So that's going to go here. Now you need to go back up here and use one of these to find the y. Well, since the top one says y will equal 4 times whatever you just got for x minus 1, that's the easiest one. So that's 8 minus 1 or 7. And again, if you finish and you're like, all right, I want to know if that's correct, then go back to your original problems and put the 2 in for the x's, the 7 in for the y's. So my first equation will become 7 equals 4 times 2 minus 1, which is true. And the bottom would become 2 plus 3 times 7 is 23, which is true. You would verify that on your calculator. So far, I have them all right. Oof. Okay, on this one, the x is alone and can be replaced with 9 minus 3y. So that's going to be what I substitute in for this x. Because if they're equal, they can replace each other. So I'm rewriting the top equation, but where there used to be an x, I'm writing 9 minus 3y, and then I go ahead and solve that. So I'm going to distribute this. I'm going to put these two together. Since they're on the same side, I can combine those like terms. I'm going to take away that 54 over to the other side. And so that gives me negative 20y equals negative 28. This one's going to be yucky in that I'm not going to get a whole number. So I'm just looking it up on Schoology because I want to make sure that I have the right answer key on here for you guys. Keys for confirmation, not copying. Well, that's actually awesome because I don't have an answer key on there at all. I'll get one on there for you. I know you're like super bored, but usually, well, you're probably super bored before I started, if we're being honest. What are you programming? I don't know why I didn't post this. I'm actually glad that I just looked. I feel like I made a mistake, and therefore I want to kind of double check that. 54 minus 18 minus 2y, negative. Oh, I am not smart. You guys, look what I did. Okay, good. I'm not going to get a Nikki number after all. I had a negative 26, and I stopped writing it. So at this point, sorry about that, teacher brain fart. Right here, I have a negative 26 because see, it was negative here, and then I just stopped writing the negative because I have messy writing. When you put negative 26 minus 54 into your calculator, you're going to get negative 80, which I love because then when I divide by negative 20, I don't get a yucky, crappy fraction like I was on my way to getting. I get 4. That makes me happier. Okay. So that's my y. I need to go find x. Well, this one tells me that x will equal 9 minus 3 times whatever you just got for y. So 9 minus 12. So x is going to equal negative 3. And I don't have a ton of room, but I can go ahead and check my answers. I go back to the top equations, these guys right here. 6 times my x minus 2 times my y, and check to see if it's 26. Put this whole thing into your calculator, and it's going to be negative 26, so that one works out. Bottom row, My x has to equal 9 minus 3 times my y. Put this into your calculator and it'll kick out a -3, so you know that that works as well. All right, so I will also get the answer key posted, didn't know it wasn't. Here I'm going to solve using elimination, which is when I'm trying to create a pair that will cancel out. So let's do that. Looking at this problem, I think it's easier to match these two up, and I'm going to do that by multiplying the top not only by a 4 to turn it into 8, but also a negative so that they will cancel out. So the top, keep in mind you have to distribute the -4 times 2, x. The negative here times the -3 actually turns positive, and then -4 times 18 gives me -72. The bottom row I don't change because I'm trying to make something eliminate, and these will, now that I match them up. These become 20y, and here you just take your calculator and you go -72 plus 12, because that's positive, and you're going to get a -60. And when you divide that 20 out, you'll have your y value for your solution. Now keep in mind, it's the y value, so it goes in the second spot. You can use either of these equations to find the x. So let's say I did the bottom. 8x plus 8 times the y that I just got has to equal 12. So that's going to turn into -24, multiplying these two. I'm going to add that 24 to the other side. And when I do that, I'm going to have a 36. And so then I can get my answer. I actually do get a decimal for that one. When I divide the 8, I get 4.5. It can happen that you get a decimal or a fraction, or however you want to write your answer. But if you don't feel like that's right, like if I was taking the test, I might worry that that's not correct. So I'm going to go back to my original problem, and I'm going to put in my 4.5 for the x, and I'm going to put in my -3, and I'm going to check to see on my calculator if it equals 18. So you literally type in 2 parenthesis 4.5 parenthesis minus 3 parenthesis -3. And when I hit enter, I get 18. So it checks. Bottom row, 8 times my x plus 8 times my y, and I'm checking to see if my calculator turns that into 12. So I'm typing it in exactly as you see it, with the parentheses and the negatives and everything exactly like that, and I'm getting 12. So even though it made me a little bit sad to get a decimal, I can tell that it's right, so I move on. This one's a little tricky because I can't match what, like I can't turn 4 into 6, and I can't turn 2 into 3. So I'm going to have to multiply both of them by something. Now, this is not currently happening to me, but keep in mind that if you're doing these problems and you end up with a problem like all the x's and y's cancel out, and you ended up with like 0 equals 4, keep in mind that that is never true, and because it's never true, that leads to no solution. And if you're doing your work and you get something like 0 equals 0, which is always true, that's going to lead to infinitely many solutions. So just kind of keep that in mind, even though so far it hasn't happened to us. So let's say that I want to match these two up. You might multiply by 6 and 4 to turn them both into 24. I like to keep the numbers small, if I think of it. So I'm going to turn them both into 12. So I'm going to make the top be by 3, and then I'm going to use a -2 on the bottom, because this top will become a 12x, and then here 9y. And then 3 times 24 is going to give me a 72. Bottom becomes -12x, -4y, and positive 28. Now, the reason I was hesitating is I, on the answer key, put the negative with the 3 instead of with the 2. It doesn't matter. So if you're looking at the answer key and listening to the video, that might be confusing, but In the end, I get the same answer. These cancel out. Either way, this turns into a 5y and this turns into a 100. So whether I did the negative with the 2 or the 3, you're going to see that I got y equals 20 in both cases. Okay. And then since I know that y is 20, I can go ahead and say, okay, that means I have to get my x from one of these. I'd probably take the top one. It doesn't really matter. So 4 times x plus 3 times the 20 that I just got equals 24. So 4x plus 60 equals 24. I'm just solving away, trying to find my x value. So 24 minus 60 gives me a negative 36. Dividing that by 4, I get a 9. Okay, so, and actually that would be a negative because a negative divided by a positive. So I'm going to go ahead and check and make sure that those work. So I go back to my original problems, like before I made any changes, and I put this in for x and I put this in for y. So 4 times my x plus 3 times my y, does that equal 24? So I'm doing that on my calculator, and I got 24. Bottom equation, 6 times my x plus 2 times my y. Does that equal negative 14? Doing that on my calculator, I got negative 14. So that's awesome. That's what I want it to be. I think what I'll do is I'll upload this as the key so that you guys can see exactly the same thing on the review key. Okay, so now it says I can use any method that I want, meaning substitution or elimination. I'm going to pick the thing that's easiest. So looking at this first problem, I think it's going to be easy to do substitution because they're telling me what x can be replaced by. So I can put that in for the x down here. So negative 2, and then I replace x with 3y minus 1 because they're up here the same. And then minus 4y equals negative 28. So this one I'm going to do by substituting. You could figure out how to do it by elimination, but it would turn out to be a lot harder. So this will be negative 6y plus 2 because the negatives cancel. And then I'm just doing my solving. These are on the same side, so they go together. A negative 6y minus 4 more is going to be a negative 10y plus my 2. I'm going to take that 2 away. And so I end up with negative 10y equals negative 30. So when I divide out the negative 10, I get a y value of 3. And it's a y value, so it goes second. Easiest place for me to find the x value is from this top equation. X equals 3 times the y that I just got minus 1. So that's going to be 9 minus 1. So x is going to be 8. And then I can go back and check my answers and make sure that that works. Here it's set up in columns where it's x's, y's, numbers. So I would do that using elimination. And you can kind of do this however you want, but I would again probably turn these two front x numbers, I would turn the x's into 12 because they can both turn into 12. So I'm going to multiply this by a negative, so that'll become a negative 12, and this by a positive 3, so that'll be a positive 12. So then they'll eliminate. So the top equation becomes negative 12. Here, the negative 2 times negative 3 becomes positive, and negative 2 times 21 becomes negative 42. In the bottom, 3 times 4x becomes positive. This becomes negative 6y, and this becomes positive 42. Ooh, you can see what's going to happen here. When you combine, this eliminates and this eliminates, everything is gone. This eliminates, So everything is gone on the right. That statement is always true. So that means there are infinitely many solutions. It's not no solution. They have every single point in common. If I were to graph them, they would have been the same line. So then this is what you put as your answer, and you have the work to support it. Okay, this is something that's on the test. Don't make this harder than it is. It's saying determine whether each ordered pair is a solution. This is a yes/no question. And the way you know is you plug them in. I'm not sure why this is scooted over so funny, but I guess it doesn't matter. So the first thing I need to do is put this in for x and this in for y. And we're putting them into those equations right up here. They're actually inequalities. So the negative is from in the problem up here. Then I put a 5 in there because that's my x, plus 2 times my y, which is this in this problem, less than or equal to 5. So do this on your calculator or in your brain. You're going to have negative 5 minus 4, so negative 9 less than or equal to 5. Is negative 9 less than or equal to 5? It is. But you have to check it in the second equation as well. So I put my x, which is 5, minus 3 times my y, and I'm checking to see if it's greater than 6. The negatives cancel, so this turns to adding, and I get 11 is greater than 6. Also true. So since it worked in both of them, I'd say yes, and I'd have to have the work to prove it. I can't just say yes without any work shown. I'm going to do the same thing now over and over again each time. So I'm going to plug in a 0. I'm using the top one now. I had a negative, and then my x plus 2, and then my y, and I'm looking to see if that's true. This turns into 4 is less than or equal to 5. That's true. Let's check the bottom. Put my x of 0 in, put my y of 2 in. This one is negative 6 is greater than 6. That is false. So the fact that that is false means that one did not work in both, and it's not a solution. Same thing again. Negative, and then my x, and then positive 2, and then my y. Is that less than or equal to 5? Negative 3 plus 2 is negative 1, which is indeed less than or equal to 5. So it works in the top. Does it work in the bottom? Let's put the x, which is 3, in, plus 3 times my y, which is 1, and see if it's greater than 6. This one's kind of tricky because I get 6 is greater than 6, but it's not greater than or equal to. Oh, actually, I copied that as a plus. This should have been a minus. It should have been my 3 minus 3y. And so I actually end up with 0, which is still not greater than 6. So this part is a no. And that makes the whole thing a no, because if it doesn't work in both, then it's not a solution. This one's a little tricky because with that negative out in front of this top, I have the negative, and then I'm plugging in a negative, then a 2, and I'm plugging in my negative 4. So these would cancel into 1, and this would turn into minus 8. So I get negative 7 is less than or equal to 5, which is true. And then in the bottom, I would have a negative 1 in for my x, minus 3, and then a negative 4 in for my y. So it turns into, these two cancel out to be positive. So I end up with 11 being greater than 6, which is also true. So this one is a yes. So there's going to be a couple on the test where you have to do that. You have to plug them in and see if it works. Okay, so when you're doing the inequalities, that's when you're going to do the shading. You've got less thans, greater thans, and all that business. So let's hop to it. I'm going to do this first one. I'm going to do the way I always do because it's more efficient. Putting a 0 in for x leaves me with 10y equals 20. So 10 times 2 would equal 20. Then I'm going to put a 0 in for y, crossing off the y spot because that would turn it to nothing. That leaves me with negative 5x equaling 20. So the only way to make negative 5 into a 20 is to multiply it by a negative 4. I also see that this is less than, so this is going to be dashed. So I connect -4 on the X with +2 on the Y with a dashed line. And then I'm going to test 0, 0. And if it's I'm trying to decide, should I shade the side with 0, 0 or not? So I go to that equation, I put a 0 in for X and a 0 in for Y. That would turn into 0 being less than 20, which is true. And since that's true, then yes, I do shade the side that has the 0, 0 in it. That's this guy. Now let's tackle the next one. The next one is in slope-intercept form. So the easiest way to graph that is to start at 1, 2, 3, 4 and go down 1, 2, 3 over 1, down 1, 2, 3 over 1. This is or equal to, so this is going to be a solid line. So I connect those dots with a solid line. Okay, now I decide. I like to pick 0, 0. So if I put a 0 in for Y and a 0 in for X, I get 0 is less than or equal to 4, which is true. So yes, I should shade the side that has the 0, 0. So I'm shading over here. And then you want to make it really obvious on the test where your shading overlaps. So colors would be nice, or if you use something darker to show, hey, this is the area that works for both. Because again, we talked about it that day, we learned this. This region has points that work in neither. The one over here that's purple, they only work in the top because that was the purple equation. Over here where it's only green, they only work in the bottom. And then where they overlap, that's where they work in both, and that's what is considered a solution. Okay, this one's kind of tricky. I'm going to start with the two that look easier. I'm going to start with this. This is from last chapter, and you got to get this into your head. That's only going to cross the X at 2. Well, the only way it can cross just at the X and never the Y is to be vertical. And it's also dashed because it's not or equal to. Okay, so that's the line. And then test 0, 0. Well, all you can do is plug the 0 in for X because there's not a Y. That is a true statement telling you that you need to shade on that side that had the 0 test point. Then let's take a look at this guy. This one only crosses the Y at 1, 2, 3. If it only crosses the Y, never crosses the X, it's going to be horizontal. The symbol is greater than or equal to, so the line is going to be solid. So I have a solid horizontal line coming across the Y-axis at 3, and then test 0, 0. But the only place I can plug it in is for the Y. Is it true that 0 is greater than 3? No. So that means I need to shade on the side that does not include it. Because you were basically saying, should I shade down here where the 0, 0 is? And the answer was no. But now I have a third one. I have the rate. I can see where these two overlap, but I need to incorporate this. So this has a vertex at the opposite of this number and then this number. So this is the pointy V shape. Absolute value means V. So I go to -2, +1, 2, 3, 4, 5, 6. And then I use this thing as the slope of the right side. So from that vertex, I go down 2 over 3, down 2 over 3. From that vertex, I go down 2, back 3, down 2, back 3. This is a greater than, not equal to, so it's dashed. So I make the V shape where I know it goes. Whoa, sorry. And then here, I just look, it says greater than, which would be higher above. And to be higher than this V or above this V would be all of this part on the outside of that V absolute value graph. So now it's kind of messy, but I'm looking for where it all overlaps. So I'm going to shade in the darkest part where all three. So all three overlap above the blue line, above the V, and to the left of the red. So right there. So that's going to be where my solutions are. Okay, this one is always confuses people, this last one, but keep in mind it's really just like 1x plus 0. So I start at 0, 0, and I go up 1 over 1, up 1 over 1. It's less than, so it's not or equal to. So it's actually going to be a dashed line that just comes straight through the middle here. And to decide if I'm going to shade it, I can't test 0, 0 because that's right here on the line. So you have to pick another point and pick an easy one. Pick 1, 0. So I'm going to test 1, 0 and then see, should I shade on the side of that point? Yes or no. This is my X. This is my Y. So I put the 0 in for Y and the 1 in for X. Yes, 0 is less than 1. So yes, you should shade the side that has that point. So my second one, which I have no idea why I graphed it first, is that. So that's this guy. Let's go ahead and do the top one. The top one is the kind that I like to make the chart for. So if I put a 0 in for X, negative 2 times nothing would be nothing. I'd have this, but negative 3 would have to multiply by a negative 4 to become 12. Then what if I put a 0 in for Y? 0 times negative 3 would wipe it out, and I would have left this part. So negative 2 times what would turn into positive 12? And the answer is negative 6. Okay, so I'm going to take negative 6 on the X, so this is my X-axis, 1, 2, 3, 4, 5, negative 6, and connect it to negative 4 on the Y. So that's 1, 2, 3, 4. It is less than or equal to, so I'm going to use a solid line to connect them. And I can go ahead and test 0, 0. So in this top problem, negative 2 times 0 minus 3 times 0 is less than or equal to 12. So 0 is less than or equal to 12. Is that true? Yes. So that's saying, yes, you should go ahead and shade on the side where your test point was. So that's going to be this part. And then your answer, your solution zone, is going to be where they overlap. So over here. So you already know, because it happened in the answer key, it happened in the review, it happened in the notes, that you have to be able to graph these absolute value ones, the vertical, the horizontal. You need to know how to do them in standard form, where I always use the table, and you need to be able to do them in slope-intercept form. So, everything on here is fair game. This is for the Thursday test. This is what you can make a note card for. So if I went over anything that you're not sure about, put it on your note card so that you can feel confident and be super awesome. See you soon. Bye, guys.